All right, so these are, I think it says sample type 3, but that's sort of like the third one. I think, in fact, these are on that chart of different types of questions. I think these are type 7, if I'm not mistaken, right? So, projectiles launched off the edge of a cliff. So I'll give you a minute or so to jot this down. You might wonder about the angle of 53.1 degrees. It'll make sense in a little bit. It's a 400-meter high cliff. It's pretty tall. And we're launching something at 10 meters per second at an angle of 53.1. And those are the things we're going to find. The reason I put that list there is sort of give you a chance to sort of think ahead a little bit. So, again, this is a projectile that is launched at an angle off a cliff. And so let's just sort of think about what do we know at the start. As always, horizontal acceleration is 0. Vertical acceleration is minus 9.8, right? Vertical displacement would be minus 400. Do we know horizontal displacement, dh? We do not. But we are to find the components: time of rise, height of rise, time of flight, range, velocity, and impact. And once you've done the first two, really, this is just sort of the next step, the next in line progression. It's not that hard. Okay, so, do I not have them? Let's find the vertical and horizontal components. So it's 10 meters per second at 53.1. So VV is going to be V sine theta, and VH is going to be V cos theta. So that's going to be 10 sine 53.1 and 10 cos 53.1. All right, so I picked 53.1 because when you go 10 sine 53.1, you get 8. And when you go 10 times the cos of 53.1, I think you get 6. Am I right? I am. So nice, even integer values for the components. Okay, so what does that mean? It means that as it's launched, the initial vertical is 8, and it's going to end up here, the vertical at 0, and the horizontal, the entire time, the VH is going to be 6. So the entire time that this thing is flying through the air, neglecting air resistance, the horizontal component is 6. Okay, so time of rise. How long does it take to get to that point there? Well, as I just said, the VI was that 8. Was it 8?
Yeah.
And here the VF is 0, right? So same as before. Same as when you were throwing the ball on a flat surface. VF equals VI plus AT. And that final velocity, vertical, is 0. And that initial is 8. Acceleration of minus 9.8 times t. So t is going to be minus 8 over minus 9.8, or 0.82 seconds. Same process as yesterday, or 2 days ago, yes. Any questions about that? We all good there? You see how it relates to the stuff from the other day? So now when we're doing the height of rise, we're looking for this distance here, t. Same process as yesterday, or 2 days ago, right? It's exactly the same. You can do it 2 ways. You can go VF squared equals VI squared plus 2AD, or you can go D equals VIT plus 1/2 AT squared. I kind of prefer the second way. because I've got it written as d equals, so that's what I'm solving for. I don't have to rearrange nothing. Initial vertical component is our 8 time 0.82 seconds plus 1/2 of minus 9.8 times 0.82 squared. 8 times 0.82 plus 0.5 times 9. Should be able to do it all in one step. It rises only 3.3 meters. Everybody good there? Okay, here's where the path diverges a bit. Here's where things change. Total time of flight. Is the time up equal to the time down? I'll go back to the original look here, and also so Blaine can see what's going on. Is the time up going to be equal to the time down? No, it's not. How come? Because it's falling off a cliff, exactly. It's got a long ways to go down, right? Time up is only to there. It's got a long ways to go down. Would you agree that the time to there is the same? And then sort of like that, right? Okay, so there's a couple of different ways to do this. So how am I going to find the total time of flight? Well, what you can do is this. Figure out the time to fall, right? Like the total time up is this 0.82 seconds. How long does it take to fall from there to there? Well, you also have to remember that you're not just falling 400 meters, you're actually falling 403.3 meters. You're falling from there. Okay? So, the total time, and I'm just going to write it out because this is an example. I wouldn't normally, I mean, you can obviously do this part in your head. If you have to write it out, that's fine. But total distance would be 400 plus 3.3. Right? 403.3. Okay, so now find out how long it takes to fall all that way. These are the same things we did yesterday when you had it falling off the table. D equals VIT plus 1/2 AT squared minus 403.3. What's the initial vertical velocity at that point right there? 0. And that makes this a whole lot easier. You put a 0 in there. And then it's exactly the same as what you did with the table. In fact, I think you learned the rule was t is equal to the square root of the displacement, minus 403.3. Half of 9.8 is that 4.9. It's always going to be like that, right? So 403.3 divided by 4.9. Take the square root of that. And you get 9.07. 9.07 seconds. I'll pause there for a second. Okay, so now, of course, you got to find the total time. I'll call it TT. So that's going to be our 9.07 plus, what was that value from before? 0.82. And can we do that in our heads? We can. 9.89 seconds is the total time of flight. Okay. Now I want to show you, I sort of briefly alluded to this the other day. I briefly sort of gave you a heads up. I like this way that I'm going to show you. This seems to be sort of brute force-ish. I'm going to show you an elegant way to do it. I'm just going to make a new blank page here. What's the overall displacement? Minus 400. G equals VIT plus 1/2 AT squared. Minus 400. What's the overall initial vertical component? 8. I don't know the time. Plus 1/2 of minus 9.8 T squared. Shady's got it figured out already. Not the answer, but he knows that it's going to be a what? It's going to be a quadratic, and he loves them. Look at the excitement on his face. He can barely contain himself. Oh, he's falling asleep on me. So I'm going to take this minus 9.8 times a half, that's minus 4.9. I'm going to take it to the other side, and I'm going to get 4.9 T squared. And the 8T is going to go to the other side and become 8T, and the minus 400 is going to stay there, and it's all going to equal to 0. And it is a quadratic. Is it factorable? Maybe, if you're really good. I'm not even going to attempt factoring that. So you're going to go good old quadratic formula. You're going to try factoring it? Or you could do this.
Google it.
Well, yeah.
Just put it into Google.
Just to Google it. Read it to me. 4.9 x squared, right? Minus 8x minus 400, is that right? Okay, so there's the quadratic, and it's been a while since I did some Desmos. There it is right there. What's the zero value? 9.888. Are you impressed? Pagans.
All of the paper.
Hey?
All of the Herald.
Call up the Herald. Get Doug EZ down here. Breaking news. What was it? 9.888. So here's my deal, because I'm such a nice guy and it's Friday and it's beautiful out. If you want to do it this way and solve it with Desmos or solve it with any other quadratic solving app software you can find, I'm good with that. Just make a little note, that's how you do it. Okay? For some reason, students like to do this one. And I want to be sure. I don't know. This one makes me feel smart. I like feeling smart, so I'm doing it this way. You like to feel smart, Josh? All right, so that's our total time of flight. And now what's the range? How far does it go sideways? The range, DH. Now you can go VIT plus 1/2 AT squared, keeping in mind that the A is 0. Oh, if I had $1 for every kid that put minus 9.8 in there. I wouldn't be a rich man, but I'd have a lot of free lunch if I had $1 for every kid that did that. Don't do that, which is why I recommend just going V bar equals D over T, because it's a constant velocity. What was that constant velocity? I think it was 6, right? Horizontally. D over 9.888. Multiply those together. I get 59.3 meters. Tell me, do you think in the old days of the Romans with the trebuchets, you guys know what a trebuchet is? Trebuchet is like, do you know what a catapult is? It might be. That's not the one I'm referring to. Yeah. To find the velocity and impact, as always, you need to know the horizontal component and the vertical component and the angle. Well, the horizontal component doesn't change. It's 6. The vertical component is simply VF equals VI plus AT. Really, this problem is not a whole lot different than 2 days ago. It's really not. The initial vertical component was 8 plus minus 9.8 times that total time. Is it 9.888? I think so. Am I right? 8 plus 9.8 negative times 9.888 minus 88.9. It's going pretty fast straight down, meters per second. But of course, you got to do that Pythagoras thing. This part, is always going to be worth 3 marks. These are like easy marks. It's the same all the time, right? Get this part right. Square that. Plus 36. So take the square root. 89.1. And of course, theta. (88.9/6), opposite over adjacent. (86.1). BTH. How do you feel about type 7 problems? There's a lot of steps, right? Is there going to be one on the exam? Not probably. Guaranteed, Connor. Guaranteed. It's the big daddy of all the projectile problems. Guaranteed. I think in the old days I did this one. We've done a question like this already, so I'm just going to skip that one. Do you want to try one on your own? Why don't you try one right now? You got half an hour. You need to work with someone you can. Ski jumpers training for the Olympics. She leads a 20-degree wrap. It's 50 meters high at 18 meters per second. The Olympic standard is a 75-meter jump. These are completely made-up numbers. Will the ski jumper make the Olympics, or will she fall short?
Like Eddie the Eagle.
Like Eddie the Eagle. I remember those days. Yeah, did you watch it?
Yeah. It was on.
He drafted this good in there.
Oh, yeah? I remember that. Was it 84 Olympics? Is that right? Or 86? No, 84. No, 86. 84 was the Summer Olympics. 65 point... Say again?
65.69 meters.
69 meters. 65.69 meters. Would everyone agree that's the answer? Yeah? Okay. That's good. If everyone agrees that's the answer, then you're all getting it. So, okay, so I'll give you time to work. We'll start Hot Wheels projectiles on Monday.